Why do engineers need to study the mechanics of deformable bodies?
So, the purpose of studying the mechanics of deformable bodies is to ensure the safety of the design against the combined effects of the applied forces and moments. These forces may be stresses and strain which can be calculated to predict the material's liability. Furthermore, it also helps engineers to determine what type of material should be used, how much of it, and the shape of the structure. It's used for everything from buildings, bridges, airplanes, cars, to the hinges of your doors, basically anything that has to withstand some type of force.
An example for this is the problem 1.3 that can be found in the book. It says that two solid cylindrical rods AB and BC are welded together at B and loaded as shown. Determine the average normal stress at the midsection of rod AB and rod BC. So the given, we have the diameter of rod AB, D1, and the diameter of rod BC, D2. D1 is equals to 50 mm. I converted it into meters, so it will become 0.05. And the D2 is 75 millimeters. Then I converted it into meter, then it will become 0.075 meter. Then find the average normal stress at the midsection of both rod AB and rod BC. For the formula, we have the average normal stress. This is sigma, the normal stress, equal P, the actual force, over area, the cross-sectional area. So this is my illustration of the rod AB having the force of 160 kN, the same as the sign here, which is the PAB. So force PAB is equals to 160 kN. Then I converted it into Newton. So we have 160,000. And for the area which is equals to pi over 4 d1 squared. Then the d1 is 0.05 meter. So the answer of area is 1.9635 times 10 raised to the negative 3 meter squared. And for the average stress AB, we have PAB over AAB. First is the 160 times 10 to the 3 Newton over the 1.9635 times 10 to the negative 3 m squared. So we get the average stress, which is 8.15 times 10 to the 7 Newton per m squared, which is equal to Pascal. Since it is Pascal, I converted it into megapascal. So it will become 81.5 megapascal as it has a tension force. And for the rod BC, we have this illustration having a force here and here and the diameter. So for the rod BC, its force is equals to the summation of Fx is equals to 0. So we have 160 kilonewton, negative 160 kilonewton, plus 120 kilonewton, plus 120 kilonewton, plus PBC, which is equals to 0. So the PBC here is negative 80 kilonewton. And then I converted it again into Newton, so I have negative 80,000 Newton. And for the area, which is pi over 4 d2 squared, d2 or the diameter of rod BC is equals to 0.075, so I get this one, its area, which is 4.41786 times 10 to the negative 3 m squared. And for its average stress, we have this PBC, which is PBC, which is 80,000 Newton over its area, which is 4.41786 times 10 to the negative 3 m squared. So I get this the average stress, which is the negative 1.81 times 10 to the negative 7 Newton per m squared, which is also a Pascal. Then I converted it again to MPa, so I get this answer, which is negative 18.108 MPa, or we shall say it is also equal to 18.1 MPa, which is a compression force. Therefore, the average normal stress at the midsection of rod AB is 81.5 MPa, which is a tension force, and at rod BC is negative 18.1 MPa, which is a compression force.